Hi everyone, and welcome to part 2 of Pre-Calculus Lesson 5.5, Inverse Trig Functions and Their Graphs. So we're looking at inverse tangent next, which is also known as arctangent. Now, just like with the other ones, we need to limit the domain. And this domain is going to be from negative pi over 2 all the way to pi over 2. So it is the right side of the unit circle. But one thing to be aware of is that tangent is undefined at pi over 2. And at negative pi over 2. So those are not actually included. So we're limiting to this right side, but we can't answer pi over 2 and negative pi over 2. Now also be aware that the tangent values are y divided by x. So it's not going to be as apparent as what you had with your sine function and cosine function, because you actually have to do that division. Now, the easiest ones to do that for are here at 0, because you get 0 divided by 1 is 0, and at the pi over 4s, because these divided will get you 1 or negative 1. But again, you'd have to do that division for the others. So it's the same idea, it's just you're going to be given one of those division answers, and you have to answer one of these radian numbers. So let's take a look at our examples. So in our example, we're asked to find each value. They want the tangent inverse of 1, tangent inverse of square root 3, and tangent inverse of 20. So I would say pause the video, see if you can figure out what those are. Remember to give the radian measure, and then hit play and see if you're right. So for tangent inverse of 1, remember to go through and look for where the y divided by x would be 1. Right here it's 0. Y divided by x right here is not going to get you 1, because remember, the y and the x have to be the same value. But right here at pi over 4, this division will get you positive 1. So pi over 4 is my answer there for part A. Now in part B, they want a tangent inverse of the square root of 3. So remember, it's y divided by x. Now, the ones that have square root 3 are pi over 6 and pi over 3. We know it's going to be in the first quadrant because it's not negative. If it was negative, it would be down here. And we know that the fraction division has to occur. So what I would recommend is just pick one to try. If it's not that one, you know it's going to be the other one. So I'm going to try pi over 3. Square root of 3 over 2 divided by 1/2. You have to flip the 1/2 and change to multiplying, and it does come out to be square root 3. So the answer here is going to be pi over 3 for part B. Now, part C, tangent inverse of 20. Tangent does not have the same constraints as sine and cosine. It's not limited to between negative 1 and 1. Tangent can be any number you want. So this can just be done on a calculator. I pulled up my calculator, I typed in tangent inverse of 20, and I got 1.5208 or so. Again, notice I hit second tangent to get the inverse tangent. I typed in the 20, and I did close my parentheses, and that got me my answer. Don't forget to make sure your calculator's on radian mode. Really important. Now, we have another example coming up. In this example, we're going to combine inverse trig functions with regular trig functions. Remember, an inverse function just undoes the original function. So we're asked to find each value here. And notice they've combined some functions here, and they don't always have to stick with the same types of functions. It can be sine combined with cosine. There's a lot that they can do with this. So what I would recommend doing is maybe pausing this video, see if you can figure out some of these, and then hit play, see if you're right. Now, the thing to be careful about with this is to make sure that you're actually staying in the part of the unit circle that it's defined for. So sine inverse is defined on the right side of the unit circle. Now, the other sine function is sine of pi over 3, which is allowed as an answer for inverse sine. So the answer to part A is literally just pi over 3. I know, it seems kind of obvious, but it's not always going to be that way. In part B, they wanted sine inverse of the sine of 2 pi over 3. Now this 2 pi over 3 is outside of where sine inverse is allowed to be. So what I recommend doing is actually finding the sine at 2 pi over 3, which happens to be square root 3 over 2. And then coming over to the correct part of the unit circle and actually finding the value that does have square root 3 over 2 as a sign value. That'll be right here at pi over 3. So the answer to B is also pi over 3. Now for part C, cosine inverse of cosine of 2 pi over 3. Notice 2 pi over 3 is where you're allowed to answer for inverse cosine. Inverse cosine is allowed in the full top of the unit circle. So the answer to C is literally just 2 pi over 3, because cosine at 2 pi over 3 is negative 1/2. Cosine inverse of negative 1/2 is 2 pi over 3. Now finally, letter D, cosine inverse of cosine 5 pi over 3. Now cosine at 5 pi over 3 is way down here. This is outside of where you're allowed to do the cosine inverse. So we take the cosine value of 1/2. We look up here for where cosine is that value. And guess what? We're back at our good old friend, pi over 3. Again, the answer is not always going to be pi over 3. It was just coincidence that these all came out to be pi over 3. Now, the last thing I have for you is the pictures of the graphs for arc cotangent, arc cosecant, and arc secant. So those inverse functions of those. We don't really use them often. We mostly stick to sine, cosine, and tangent. So this is what the graphs actually look like. Arc cotangent is here. We have the pi over 2, and notice it goes on forever in this direction. And same thing here. Arc secant has different starting points, but it looks very similar. Same thing with arc cosecant. Again, slight differences in how things work with them, but this is what the graphs will basically look like. Okay? So that's it for this lesson. Make sure if you have any questions, you maybe talk to a classmate, or you write them down and send them to me through email, or talk to me the next time we have class. Okay?